Okay, so we're on to lesson 3 in unit 1. And this lesson concerns using the midpoint and distance formulas. So it would be helpful at first for us to just focus on the midpoint formula, what it is, what a midpoint is, and what it does to a segment, and then how to find it in a coordinate plane. So we're going to talk about two things here. A midpoint is a point that divides a segment into two congruent segments. It divides that segment into two equal length segments, okay? So midpoint is a point that divides a segment into two congruent segments. A segment bisector. Bisector means it's some sort of geometric object that cuts something in half, okay? It intersects it at its midpoint. So a segment bisector could be a point, it could be a line, it could be a ray, it could be a line segment, or even a plane. So it's any geometric figure that intersects the segment at its midpoint, okay? So that first example is going to be an example of a segment bisector. So we want to find the length of RS. So we want to find the length of the entire segment. So we look at this, VW here, this is a segment bisector. It is a segment that is bisecting RS. If it is bisecting RS, that means that RT and TS are the same length. So that means TS is also 21.7 units long. So really, to find RS, I take 21.7 and I multiply that by 2. So 21.7 times 2. So the length of that entire segment is 43.4 units. So RS equals 43.4 units, okay? Segment bisector divides that segment or intersects it at its midpoint, meaning I'm cutting this length in half, okay? So, real quick, there's a guided practice here. I want you guys to look at this, work through it, pause the video for a few seconds or pause it while you're working on it, and then I'm going to show you the solution and explain my solution. Okay, so for number 1, we're finding the length of AB. Much like the last problem, we have this ray CD. That ray is bisecting AB, meaning C is the midpoint. So that tells us that AC and CB are the same length. You see these little hash marks here? Those tell us that AC and CB are the same length, meaning I can say CB is also 2¼ units long. Me knowing that, I basically just double the length of AC to get the length of AB. So 2¼ times 2 is 4½ And if you're more comfortable with decimals, it's recognizing that 2¼ is really 2.25. That times 2 is 4.5. So I'd accept either of those as answers, 4.5 or 4½ either way, all right? So just make sure you're understanding a bisector is any geometric figure that cuts the length of a segment into that cuts the length in half. That segment is cut into two equal parts, okay? Next, moving on to example 2 here. It says point C is the midpoint of segment BD. Find the length of BC. So length of BC is what we're trying to find. Thing to notice here, if it's C is the midpoint, that means that BC and CD are of equal length, meaning an equation I could set up and solve, I could take this expression that stands for BC, that stands for the length of BC, and set it equal to the expression that stands for the length of CD, 2x plus 3. And then I can solve that equation. So for me to solve that equation, sometimes it helps to just divide, show some sort of barrier between the equal sign to compare the two expressions. So for me to solve this, I think my first step, I would want to subtract 2x from both sides. So this is x minus 2 on one side, and that equals 3. And then for me to solve this out, I'm going to add 2 to both sides to solve. X is 5. Now that's helpful, but that's not answering the question. I asked to find the length of BC. So to find the length of BC, I'm going to take what I know for 5 and substitute it into BC. So BC is equal to 3 times 5 minus 2. And I can do a little bit of mental math here. 3 times 5 is 15. 15 minus 2 is 13. So BC is 13 units long. So it's not just enough to solve. We've got to solve and then substitute in to find the length of that segment. So again, a little check-in here. Be a good time to pause the video, work through the example, wait a few seconds, and I will show you my worked out example and explain how I got there. Okay, so here's my solution for the got it. And I know there's a lot of work going on here, but I just want to talk through my steps and show you how I did this. So for this particular example, I've got these segments. I know that K is the midpoint, meaning I know that this splits JL into 2 equal parts, okay? This segment is equal to this segment, congruent to it. It means they have equal length, meaning I can take these two expressions that represent the length and set them equal to each other. So I go through the process of solving that equation. I added 3 to both sides, got 8 equals 5x plus 5. Then I subtracted 5 from both sides, got 3 equals 5x. I divided both sides by 5. I got 0.6 as my value for x. I then went ahead and said I need to find the length of KL. So I substituted this 0.6 in for x, and I evaluated that to get 6.2 for my length of KL. So it's about setting up and solving an equation and then thinking about what is the length I'm asking you to find in that particular problem. So it's a good point to stop, move on to the next step in your lesson, probably some sort of activity to kind of practice this and get the idea of a midpoint or a bisector down, and then you can move on to actually using the midpoint formula in the coordinate plane. Okay, so move on to the next step in the lesson.